Hello, and welcome to another exciting edition of Ponderosa Chemistry. Today, for my classes, this should be a little bit of a review. I don't know where the other chemistry classes are, so this may be a bit of review for you as well. But what we're going to do is basically take metallic ions, okay? So let's ask ourselves, number one, what does metallic mean? Okay, so think about it. I'm going to give you 1 second. Okay, so basically, metallic is we're looking at anything on the left side of the periodic table. Okay, ion, think what that is. Something that has a charge, either positive or negative. Now, metallic like to lose electrons. Electrons are negative in charge. So if the electrons are lost, there's more protons than electrons, so the metallic ions are usually, they have a positive charge. A positive charge. Okay, because they lost the electrons. They like to lose electrons. Okay, so what we're going to do is we have solutions of these ions. Okay, and we are going to put them in a flame, and we're going to see what happens. Now, let's think for a minute. Okay, so if I have an ion, it's going to have electrons that are in their normal state right now. That means they're the most stable. They're at rest. They're happy right now. They have a normal electron configuration, so they're happy. Well, what we're going to do is we're going to add heat. What do you think that heat is going to do to those electrons? You're exactly right. They're going to excite those electrons. And when those electrons get excited, they jump up energy levels. Or like I've told my class, they crawl up the ladder, or the shells, they crawl up the ladder, absorbing energy. Absorbing energy. Well, they'll get to a certain point where they become unstable. Okay? They jump though, they go up the ladder, they go up energy levels, they become unstable, and then what they do is they've absorbed all this energy while they've crawled up the ladder, and they become unstable, and then they're going to fall back down to their ground state or their normal state. And as they do that, remember, the electrons are going to give off or release energy, and it's in the form of light. Okay, in the form of light. One of the lessons you had to do is the hydrogen emission spectrum. We did that before Christmas. So with that, what happens is we used a spectroscope or a prism, and there were certain lines where the colors of hydrogen went to. They're wavelengths of certain lines. Well, what happens is what we're going to see is we're going to see all those different colors that you saw in the spectroscope combined together to give off one certain color that's a characteristic of that ion or even that element. So just that color is specific to that element. It's like a fingerprint. If you know that the color is such, and that's what, let's say, calcium is, then you know when you see that color, it's calcium. So what we're going to do is we're going to go back to the workstation. Notice safety goggles. Okay, now we are using a flame. So ladies, I would recommend that you tie your hair up. Okay, you don't want to catch on fire. So, but what we do for this lab is we turn off the lights. Okay, so I'm going to turn off the lights, and then we're going to walk back to the counter. Okay, and we are going to see different colors. Now, if I was you, I would have a pencil and paper. I should have told you that sooner, but I would have a pencil and paper. All right, so come back. Okay, so I know it's dark. Here's all our solutions. Okay, there's our flame. Notice the flame. I have a flame within a flame. That's what you want. Okay, that's what you want. So what I'll be doing is I'll be dipping a metal inoculating loop, a metal inoculating loop in these solutions, and then I will put it over the flame. Now, this is kind of hard or more difficult than you think, because when I put this inoculating loop, this doesn't have anything in it. It's going to give off a color. Well, let's see what color it gives off. Okay, it gives off whatever you want to call that, yellow, orange. So you have to make sure that you understand that, because when we put these solutions in the flame, they're only going to last for a little bit, and then they're going to get burned off, and then you're going to be left with the inoculating loop. So that color that you see there is the color of the inoculating loop, so don't get it confused with other colors. So what we're going to do is, what I would write down if I was you, strontium. The first one we're going to look at is strontium. Okay? So when I put this inoculating loop in this flame, this color should represent strontium. Okay? Oh, so did you guys see it? Okay, you can see that there's still some, but there was red. Oh, nice one. There was red. Okay, you can see some red there. Let's try it one more time. So strontium looks like it's red. See that? See that? Red. Red. Okay, good job. So strontium, red. That's what you need to remember. Okay? So the next one that we're going to have is iron. Now, let's see what iron is. Okay, so if you saw it, it was hard to see, but iron, I'll do it again so you can see better. See, it burns a little blue. Now, again, it's one of those things, if I put that back in there, what you're going to see is the inoculating loop. Okay? So you got to be careful of that. So that was iron. And so what we're going to put for that is blue. So let's try that again. Okay? We've been having trouble with our iron. So let me Get it in there. Now, let's try again. Make sure my inoculating. I'm trying a new inoculating loop. Okay. There we go. So what we should have got is the gold. Okay. As I put it through there quickly, you can see that it turns gold at the top there. I'll do it again. See, so gold for iron. Now, let me get another loop. This is sodium. So for iron, write down gold. Oh, that's a good one. Now, oh yeah, that was a good one. So what they're going to say for sodium, okay, is that sodium, if we take a look at it, okay, its colors should be, now that actually was a good one. You may not notice the difference between the two, but sodium, remember, iron was a gold, or it should have been a gold. This was really good because this is really good. As you can see, that bright yellow right there. And I go all the way down, bright yellow. Really good, really good. All right. So sodium is yet bright yellow. Lithium. Okay, so this is lithium. Oh, beautiful. Beautiful. Look at that red. Wow. Are you kidding me? Whoa. That's worth one more try. Okay, let's go. So, lithium. Lithium is red. That's a great one. Great one. Red. Look at that. I mean, look at that. Oh, that's beautiful. So, write down lithium is red. Okay, lithium is red. So now what we have is potassium. Let's see how our potassium works. Okay, oh, if you can see it, it's a light, oh, that was nice. That was a light purple. Okay, so you have to look close, but that was a light purple. See it? See it? Okay, so light purple for potassium. Then our last one is copper. Okay? So the last one is copper. Oh, green, blue. Look at that go. Yes. Green, blue. Whoa, that's cool. Look at that. Doesn't get much better than that right there. Okay, we'll do it one more time. Green, blue. Okay, so that was copper, okay, greenish blue. So now, remember, all of these are characteristics of that, let's just say, element. When it's falling down, it's releasing energy in the form of light. So if you remember from your 9th grade lab and you looked through the spectroscope and you saw different emission spectra, you know, a red line, an orange line, a yellow line, well, those colors are all mixed together now. That's why we see them as we do now. Now, if we had a spectroscope or prism diffracting, grating, we'd be able to separate those colors according to wavelength on the spectroscope. So what we're going to do now, okay, is I'm not going to tell you what I'm going to put in the flame, because remember, the color is a characteristic property. So based on what you've just done, I am going to put a substance in the flame, and you have to identify what that substance is based on its color. Okay? So here we go. Here's the first one. Okay? So write down what you think that one was. Okay? Now, here's the second and last one. Okay? Write down what element you think that was. Okay, on the first unknown one, if you said lithium, you were correct. On the last unknown one, if you said copper, you are correct. Okay? Well, that will conclude today's lab on the flame test. I hope we got something out of it, and I can't wait to see you for the next edition of Ponderosa Chemistry.